So in this series of advanced data structures and algorithms, we have covered the topic of list, sequences and vectors, all those abstract data type which are available in standard template library of C++. We have talked about them in detail, and today we are going to kind of move to our next topic, which is about hashing. So when we talk about hashing, this term hashing has also been explored in our course of data structure, but here as we are moving towards the advanced functionalities of data structure, we are going to get into kind of more details of hashing rather than just exploring it on a shallow basis. Because in advanced data structures and algorithms, this hashing covers this hashing serves as a very important topic. So when we talk about any of the data structure, what are the main functions which you can what are the main operations which you can kind of think about to be operated upon that particular data structure. So main operations which are common to every data structure is about your kind of insertion, it's about your deletion, and it's about searching. So when we talk about insertion and deletion in any data structure, and that too on a particular position, maybe the data structure is ordered like binary search tree, and we want to insert a key. So that key has to be inserted at a particular position, or maybe your data structure is kind of like a heap, that again that kind of key has to be inserted at a particular position. So now what I am trying to establish here is, in order to go for insertion and deletion also, we need to search the position from where it is to be deleted, from where the element is to be deleted, or onto which position that element is to be inserted. So that position is to be searched. So now this hashing revolves around this term searching. If we talk about the sequential search, the data structure, let us say the table or the array that is going to store the element is searched successively one element at a time in order to determine which cell of the table or of the array is to be checked, and at every element what is being done is a key comparison which determines whether an element has been found or not. So there involves a key comparison with the content of all the we can say cell elements. Similarly, if we talk about binary search, the data structure or kind of that array that is storing the elements is divided into two halves in order to determine which portion is to be checked, either it is the left portion or the right portion, and then again some comparisons are involved in order to determine whether that element is present or not, and if present at which particular position. Similarly, if we talk about binary search tree, so in binary search tree, the decision to continue the search in a particular direction is accomplished by comparing keys. So here the bottom line is, among the three major operations to be performed on a data structure, which are insertion, deletion and searching, insertion and deletion also involves searching in some form. And when I am talking about searching, this searching is actually accomplished with the help of comparison of keys. So searching is something which we are going to kind of make efficient today with the help of hashing. When we talk about searching, can we have such approach to searching which calculates the position of the key in the table or in the data structure based on the value of key. So for example, let us say this is a key x, so this has to be kind of stored at a position x dash, or let us say this is the key y, this is to be stored at the position y dash. So, this actually means the value of the key is the indication of the position of that key in the data structure, or more specifically we can say the value of the key is the only indication of the position. So, when a key is known, the position in the data structure can be accessed directly without making any other kind of preliminary test that compare this with the root element or compare this with the middle element, as we do it in your binary search or binary search trees, or even comparing it with the first element then comparing it with the second element. Without any such preliminary test, if we have a key, that position in the table can be kind of directly accessed. So, this is what the agenda for hashing is. If you know the key, the position in the table can be accessed directly by that key or by value of that key, and in order to access that position you need not to make any other comparison, any other test, as we did in our kind of previous searches or previous search methodologies. So, that this means when we talk about a sequential search, the search time was order n. When we talk about binary search, the search time has become log n, and now when we talk about this type of kind of accessing the position which is based on the key, it will be an kind of an order 1 operation. So, we have reduced the search time from order n to order log n, and from order log n to order 1. And also, because I am talking about a factor which is order 1, there is no n in this. So, regardless of the number of elements being searched, the runtime is always going to be the same. So, hashing is such a kind of functionality or such a kind of technique in which the search time is independent of number of elements. But a disclaimer obviously is here that this is kind of an ideal situation, and in a real life situation ideal situations can only be, we can say approximated. We cannot say that this will always happen. There are scenarios in which your application may behave weird, in a weird manner because of non-existence of this ideal situation. So, let us try to understand what is this hashing. Basically a technique which is used in data structures that efficiently stores and retrieves data in a way that allows for quick access. And when I am saying quick access, I am not talking about order n, I am not talking about order log n, I am specifically in ideal situations I am talking about order 1. So, this hashing involves mapping data of a specific index in a hash table, or let us take, for the sake of simplicity as of now, we can take it as an array of items. So, this hashing involves mapping data of a specific index in a hash table which is in the form of an array using a hash function that enables retrieval of information based on its key. What does it mean? As I was telling you in the previous example that if the value of the key is x, the position in the array or the position in the hash table is x dash. If the value of the key is y, then its position is y dash. But here we need a function which is going to convert this x into x dash and which is going to convert this y into y dash. That means hash function we are going to require in order to convert the value of the key into the position. So, the conversion of x into x dash has to be done with the help of a function, and that function is known as hash function. So, in hashing we are aiming to achieve all the 3 operations which are search, insert and delete in order 1 time on an average. because if search is being done in an order one time, then insertion at any searching means you have accessed the position. Now when you have an access to the position, insertion is obviously a constant time insertion will become a constant time operation after that. And similarly, when you have accessed the position, deletion of an item from that particular position to which you already have an access, it is kind of an constant time operation. So it is just the searching thing which is going to take order one time on an average. After accessing the position, or after we can say catching the position, your search obviously is done. Insertion and deletion will be done in kind of no time, we can say. And hashing, when we talk about, is mainly used to implement a set of distinct items, and we can say dictionaries. So dictionary, if you are kind of aware, it is a data structure which store the elements in the form of key value pairs. So now what is the agenda? What are we actually looking for? We are looking for a function h that can transform a particular key, let us say x. Now this key could be anything. This could be in the form of a string, this could be in the form of a number, or maybe a record. That key, let us say x, has to be transformed into an index. Index of what? Index of the table, which is used for storing items of the same type as that of x. And this function h is nothing but your hash function. So basically, hash function is a function which can transform a particular key into an index, and this key can be of any form. As I have told you, it could be a string, it could be a number, maybe a record or something of something else. So this function h is called a hash function, and if your h transform different keys into different numbers always, it is called a perfect hash function. Again, kind of we can say an ideal condition, which is kind of difficult to achieve. So when we talk about perfect hash function, getting this perfect hash function or creation of this perfect hash function is always the goal. And the table in this situation of perfect hash function will have to contain at least the same number of positions as that of the keys, or at this of the elements being hashed. So for example, if you have 10 elements to be put into a table, your table must have at least 10 slots. If less than 10 slots, then the function cannot be the perfect hash function, because perfect hash function, different keys to be given different index. So if indexes are less or the size of the table is less, at least some of the keys will go into one particular slot by pigeonhole principle, at least one will be there. So then it's not going to be a perfect hash function. Even after kind of having the elements, having the size of the table equals to the number of elements, it is not always guaranteed to have your hash function as a perfect hash function. That means all the keys will be hashed to the different index, even if you have sufficient number of slots in your hash table, or even slots are more as compared to your items. Then also a situation of perfect hash function is not guaranteed. Why it is not guaranteed? I will tell you in some of the upcoming slides. But the another situation here in generation of this perfect hash function is, I have told you that there are, let us say, 10 elements. So the size of the table should be at least 10, but it is not the situation always that the number of elements is known ahead of time. Sometimes we may have situation in which these elements are kind of coming continuously, or getting entering continuously. So one such example is your symbol table, which a compiler keeps in, which a compiler keeps a track of in order to, store the variables used in a program. So, symbol table, we can say that is a table which is used by a compiler, or which is, created and managed by the compiler in order to, keep the variables of a particular program. So, real programs use only a fraction of vast number of possible variable names. There could be, huge number of variable names which is possible as per any specific programming language rules. So here we can say a table of, let's say, 1000 or maybe 2000 cells is usually adequate, but this is not a situation in, kind of all the scenarios. We may have, keys coming in on dynamically, and also it is not possible to estimate or even to, overestimate the size of the table always. Also, even if the table is, kind of large enough to accommodate all the variables in the program, the agenda is to design a function h that allows the compiler to immediately access the position associated with each of the variable. So, this is what kind of, a complete scenario, what about the hashing, or in which kind of scenarios this hashing is going to be used. Now, when we talk about the data structure which is used for hashing, or the hash data structure, it is one of the most widely used data structure. It is used as commonly as these arrays are used. It mainly supports search, insert and deletion in order one time on an average, which is obviously more efficient than the popular data structures arrays. The searching is order n. If we talk about linked list, that is also an order n. If self-balancing binary search trees are talked about, then it is order of, kind of their height at least, not 1. So, this order 1 is a time which is more efficient than all other, popular data structures. Now, in which kind of scenarios? One situation I have given you about the, symbol table inside the process of compiler, in which we are going to use the hash table or hashing. Apart from that, we also use hashing for dictionaries, for counting of frequencies, or maintaining the data for quick access by the keys. Real world application corresponding to hashing requires, hashing includes cryptography, your caches, symbol tables I have already told you, dictionaries are also there. Apart from that, we also have database indexing. So, hashing is a topic of, kind of, we can say a prime importance, considering its real world, huge real world applications. Now, how this, hashing is being implemented as far as, general programming languages are concerned. So, there are mainly two forms of hashes which are typically implemented in programming languages, and this is a, kind of a general or a typical scenario. This is not again an exhaustive case study. So, the first form is a hash set. Hash set is a collection of unique keys, and if we talk about the implementation of hash sets, we have set in Python, sets in JavaScript, unordered set in C++, and hash set in Java. So, all these are, implemented in the form of hash sets. And the second implementation of hashing can be in the form of hash maps, which is a kind of a collection of key value pairs with key being unique, and the implementation here is can be in the form of the way we implement dictionaries in Python, the way we implement maps in JavaScript, unordered maps in C++, and hash map in Java. So, hash set and hash map, these are the two forms of hashes which are typically implemented in kind of programming when we talk about. With this background of hashing, let us move further to components of hashing. So basically there are three components of hashing. One is the key, another one is the hash function, and third one is the hash table. So when we say key, it could be anything, a string, maybe integer, or it could be a record also. It is fed as the input to the hash function. This hash function is actually a technique that determines the index or location for the storage of an item, for the storage of that key in the data structure. So key is kind of an input to the hash function. That hash function receives the input key and returns the index of an element in an array. That array is called hash table and the index is known as hash index. So basically hash function is something, a kind of a technique, or maybe a function, or maybe an algorithm that receives the input key, returns the index, that means the position of the element in the hash table. Then the next component of your hashing comes up as hash table. Hash table is typically an array of list, we can say. It stores the value corresponding to the keys. Hash stores the data in an associative manner in an array where each data value has its own unique index. So basically an array of values in which each hash index is corresponding to some key values. So that's what your hash table is, and in order to kind of understand this concept of hashing, we have a kind of figure here. So this figure is showing all the three components. One is key, another one is hash function, and third one is hash table. So let's say we have three keys here named as key 1, key 2, key 3, and one at a time. Obviously these keys are supplied to hash functions as input, and this hash function is giving you kind of we can say index of the hash table on which this key has to be kind of stored. So for example, your key 1 has to be stored at a particular value, let's say value underscore 2. Then you have your key underscore 2 which is to be stored at value underscore 3, and you have key 3 which is to be stored at value underscore 4. So in this way we are going to kind of convert a key into an index with the help of a hash function, and then we will kind of implement our hashing. So let us try to understand it with the help of an example, that how does this hashing work. So for example, we have a set of strings. The set of strings has the three elements AB, another element is CD, and third element is EFG, and these strings are to be stored in a table. And let us assume that we know that hash functions, it's a kind of a mathematical formula which is going to be used to calculate the hash value, and this hash value will act as the index of the data structure, where that key has to be stored. So now let us assign some numbers. We are going to give you here an example of hash function. So let us say A is assigned as a number 1, B is assigned as a number 2, which is nothing but their alphabetical position in in the order. Next, in the next step, we will take the numerical value by summation of all characters of a string. So for example, AB, we have 1 corresponding to A, 2 corresponding to B, so total becomes 1 plus 2 as 3. Similarly for CD, which is 3 plus 4, C has the position 3, D has the position 4, we have 7. Then we have E, F, G, so which is 5 plus 6 plus 7, 5 corresponding to E, F and G has 6 and 7 respectively. So the summation has become as 3, 7 and 18. So actually this 3, 7 and 18 are kind of your we can say your hash index or the position inside the hash table. Now assume that we have a table of, let us say, size 7 only. So the hash function here which we are going to be used has to be some tweaked version of this summation, because if we have the size of the hash table as 7, we can only store 7 elements up to 7 elements up to index 7 into that. But here if we directly implement, we cannot store a key value which is having 18 to the position 18, because there is no position 18 in the table. So the hash function that is used here will be the sum of characters in key mod table size. So key mod table size, that means we can compute the location of the string in the array or in the hash table by taking sum of strings mod 7. So for example, AB we have 3, so 3 mod 7 is 3. Then CD we have 7, so 7 mod 7 is 0, and EFG we have 18, so 18 mod 7 is 4. So now we have 3 indexes, 3, 0 and 4. So AB is to be stored at position number 3, CD at position number 0 and EFG at position number 4. So here a mapping of keys with indices of array has been shown. So CD at position number 0, AB at position number 3 and EFG at position number 4. So in this way we can say this hashing can be implemented, or this hashing with all these 3 components of your key, hash function and hash table can be implemented. Now this technique enables us to calculate the location of a given string using a simple hash function, and the hash function was the summation mod 7. So we can conclude that the idea of hashing seems like a great way to store some of these key value pairs in a data table, if we can say. So in this lecture we have started with the concept of hashing, why this hashing is important and how this is going to change the scenario of efficient searching. Then the component of hashing we explored, and we tried to understand the concept of hashing with the help of example. Here is a list of references which is being used for the preparation of lecture. I will see you in the next one. Till then, take care. Goodbye.